So in the past, we've plotted coordinates using Cartesian coordinates where we've had an x-coordinate and a y-coordinate, and we're used to that. And we know that if I get x as 3 and y as 1, I get a point. Sometimes that's not the most efficient system to use though. Sometimes it'll be easier to use a polar form. Now some of this should look a little familiar because when we started talking about the unit circle and we looked at how the values were found on the unit circle and some things, we came up with a few equations, and one of those equations related to the radius of the circle, and it had an angle where we did the cosine of the angle or the sine of the angle, and that gave us a way to figure out those coordinates. So a polar coordinate, here's the definition that you get in the textbook, consists of an ordered pair of the radius r and the angle theta, where theta is the angle and it's measured from the standard position. So for instance, this would be 0, this would be pi over 2, and then 1, 2, 3, 4, 5, 6. So each of these is pi over 6 on this graph. Pi over 6, this is pi over 3, 2 pi over 6, and so on as you go around, all the way up to 2 pi. So we're going to actually work with plotting that. So those are the angle measures, and then each circle is a radius. So there's a radius of 1, 2, 3, and this out here is the radius of 4. So I'll actually have some graph paper for you to use when you plot some points. So we're asked to plot these polar coordinates, and again, we start at 0. So this is 0 degrees or 0 radians. 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, we're going to look at this. That's pi over 2, that's 0 radians. This is pi radians. So this angle is pi over 6. This is 2 pi over 6 or pi over 3. This is 2 pi over 3. This is 5 pi over 6. So we keep going. All right. And it follows some values that you should be familiar with by now from your unit circle. Now we're missing a few, but we've got most of our stuff that we need. So, if you look at my part B, I've got negative pi over 4. So we are missing a few. But let me go ahead and finish this up. All right, so we're missing some of our critical angles from the unit circle, like pi over 4 and stuff, but we've got enough that we can do a general plot on here, and then I'll show you how to use Desmos as well to do this. So the first thing I'm doing, I'm just labeling some of these angles so we can get started. And then I want you to notice I've got a circle in here. That's radius of 1, there's 2, there's 3, 4, 5, 6, 7, 8, all the way out to 9. So when I plot this first point, 7, and 7 pi over 6, here's my angle 7 pi over 6 in this bottom, the third quadrant. I just need to go out this line, 1, 2, 3, 4, 5, 6, 7, and that's where point A will be. Since it's part A, I'll just call it point A. When I do 6 and negative pi over 4, I need to be on the sixth circle out at negative pi over 4 degrees. So I can do that a couple ways. I can either go, I start at 0 and go backwards to the negative pi over 4, which is right around here. Or, and I need to know that it's just like we did with our other stuff and our angles, where if I add 2 pi to that, I get 7 pi over 4, which is where it's also going to be at. So Point B is 6 circles out, so it's around, actually, that's the 7th circle. It's right here. And then this is a little trickier, all right? Pi over 6 is this angle here. And I'm told to go -3. So instead of going to the 3rd circle, like you would maybe believe, so I have to go back 3. 1, 2, 3 along that same angle. And there's where point C would be. So if we were to, and I was going to show you how to graph this in Desmos, but Desmos does not just graph polar coordinates like this. You can graph polar equations, which we'll get to later. All right. Now, some of these things should look very familiar. To convert between polar and Cartesian coordinates, we're going to use some relationships that we're already familiar with. So we've seen this before where we know that the cosine of theta is equal to x over r, or that x is equal to r times the cosine of theta. We've seen that sine is equal to y over r, or that y is equal to r sine of theta. And we've used this for the circle before, where x squared plus y squared is equal to r squared. So we're also going to use the tangent of theta being y over x. And if you look at your reference sheet, these are all on there with your unit circle. All right. So that's the good news. Those aren't anything new. We've used some of these before. So let's just convert some of these. All right. So here r is equal to 7. Theta is 7 pi over 6. And we can go ahead and get our equation set up. So x is equal to r cosine theta. Y is equal to r sine theta. And we just plug these in. So we get 7 cosine 7 pi over 6 and 7 sine 7 pi over 6. And we know what that is from the unit circle. So the cosine of 7 pi over 6 is negative square root of 3 over 2. And the sine of 7 pi over 6 is negative 1/2. And that gives us an answer for part A of negative 7 square root of 3 over 2, comma, our y value would be negative 7 over 2. All right, so for part B, we're doing the same thing, except x is going to equal 6 cosine of negative pi over 4, and y equals 6 sine of negative pi over 4. So again, we use our unit circle and realize that negative pi over 4 is the same thing as 7 pi over 4. We get 6, and we get the square root of 3 over 2 for the cosine, and we get negative 1/2 for the sine. So that gives us an x-coordinate of 6 divided by 2, which is 3 square root of 3. And then 6 times negative 1/2 is negative 3. And then for part C, we're doing the same exact thing, so except we're using pi over 6 and negative 3. So the cosine of pi over 6 is square root of 3 over 2. And the sine of pi over 6 is 1/2. And that gives me my final answer of negative 3 square root of 3 over 2 for my x-coordinate. And my y-coordinate would be negative 3 over 2. And sometimes we have to go the other way. So in this case, we have to go the other way. Now, 4, 2, this is first quadrant. 3, negative 5 is in the fourth quadrant. Okay, we'll use that information as we go. So we got to remember a couple things. We need to know the radius and we need to know theta. So it doesn't matter where you start, you're going to use both of these equations. Since we already know the x and the y, let's use the tangent of theta being y over x to help us figure out the angle. And then we need to know the radius. Well, we know that the radius squared is just r squared is x squared plus y squared. So we can plug in x and y to these and figure this out. So tangent of theta is equal to 2 over 4. And then theta is equal to the inverse tangent of 2 over 4, or 1/2. And that gives us theta being 0.46365, roughly, if you round. And then r is going to be 4 squared plus 2 squared. So that gives me 16 plus 4, which is 20. So r is equal to the square root of 20. And if you remember right, you can pull 4 out of that. Square root of 4 is 2. Square root of 5. So if we were to write this as a coordinate, we would do 2 square root of 5, comma, 0.46365. All right. Same thing here with the tangent. Now, this one's going to be a little different. We're going to get the tangent of theta equal to negative 5 over 3, because we're using y over x. And if I do that inverse tangent of that, I get a negative number. Now, we could keep that negative number, or since we know it's in the fourth quadrant, we could add 2 pi and get our angle in radians in the fourth quadrant. So either way is fine. I would say let's use this one since it's a positive number. And then r squared is going to equal 3 squared plus negative 5 squared. So that's 9 plus 25, which is 34. And the radius is equal to the square root of 34. So our final answer is square root of 34, comma, 5.252 as a polar coordinate. Sometimes we also have to convert to a polar equation. There's going to be times when doing a polar equation is going to be a lot easier than having Cartesian coordinates. So we've got this. Now we just need to remember that x equals r cosine of theta. Is one of our ways to convert. So since that's the case, we know what x is. So 3 equals r cosine theta. And we're going to solve this for r. So most of our polar equations are going to start with r equals something. So in terms of theta. So I'm just going to divide both sides by the cosine of theta here. And 3 over the cosine of theta is the same thing as 3 secant theta. And that equals r. Or we could technically rewrite it better by putting r first. R equals secant 3 secant theta. That's our final answer. And next time I'll show you how to graph these with Desmos. And you'll see that that's the same line as x equals 3 on a Cartesian plane. So here we've got y equals 4x squared. We're going to have to remember a couple things. Y is equal to r sine theta, and x equals r cosine theta. If we use those, we can simplify this down and get our final answer. Okay? So I'm just going to replace y with r sine theta. And I'm going to replace x with r cosine theta. And then we're going to do some solving. Alright, so r sine theta equals 4, and that's going to be r squared cosine squared of theta. Now, we can get rid of the r. We can divide an r out of both sides. It won't matter in this case. If we were solving a regular equation, those kinds of things do matter, but in this case, it's not going to matter because if r is 0, we don't have anything. So I've got sine of theta equals 4r cosine theta. And now I'm going to get r by itself by dividing this by 4 cosine theta on both sides. It's actually cosine squared, my bad. 4 cosine squared theta. And that leaves me r on this side. And now you can write this a couple ways. I'm going to go ahead and write 1/4 out front because the 4 is on the bottom of the fraction, so that's just the same thing as multiplying by 1/4. Sine divided by cosine is tangent. So let me rewrite that out as it's sine of theta over cosine theta times 1 over cosine theta. And then that's just 1/4 tangent theta for the sine over cosine, and the 1 over cosine is the secant theta. So r equal to that is my final answer. Again, they all have some similarities. If you've got x squared plus y squared, you should know that r squared equals x squared plus y squared, and y equals r times the sine of theta. And then we just substitute these things in. So this is just r squared 4 times this r sine theta. Now again, I've got an r on both sides. Not going to be much of an equation when r is equal to 0, so we can get rid of that. If I divide both sides by r, I get r equals 4 sine theta. Alright, so again, I'll show you some more next time with using Desmos. I wish it would plot the regular polar coordinates like we had at the beginning, but that's just going to be something you're going to have to do by hand. And then eventually we'll graph this equation on Desmos, and I'll show you that these two equations are the same next time. Alright, so on the first few problems, I do want you to plot the points as well. It helps you to convert from polar to Cartesian, and on 2 through 10, I want you to go ahead and plot those. So I've got graph paper for you for those.